You know when you look up at a skyscraper and just marvel at the engineering? Well, what if I told you one of the most sophisticated buildings on Earth isn't made of steel and glass, but of mud and saliva? It's time to meet nature's smartest architects.
Yep, we're talking about the termite mound. I mean, these things can tower up to 8 meters high, and they're home to colonies of over 1 million termites. They're absolute masterpieces of climate control, all built by some of the tiniest engineers on the planet.
And that really is the central mystery, isn't it? How do millions of tiny, blind insects coordinate all of this? How do they engineer a masterpiece so perfectly tuned to its environment with zero blueprints and no architect's insight? Well, the answer is even more incredible than you can imagine. Okay, so to really understand the genius behind this mound, we've got to appreciate the problem it's actually trying to solve. Because this isn't just a home, it's a full-on life support system.
You see, a termite colony is basically a superorganism. And just like any living thing, it needs to breathe and keep its internal conditions stable. Now, out in the African savanna, temperatures can swing by a whopping 20 degrees Celsius in a single day. But inside, the termites need a super stable, really humid environment for the fungus they farm for food. Oh, and on top of all that, they've got to get rid of all the carbon dioxide they produce. It's a huge challenge.
And what's really fascinating is that different termites have come up with totally different solutions. You've got the magnetic termites in Australia, for instance. They build these incredible wedge-shaped mounts that are perfectly aligned north-south. Why? Well, it's a clever way to dodge the brutal midday sun while still catching the morning and evening rays. But the African Macrotermis species, they have an even more dynamic solution. It's less about where you point the building and more about creating a living, breathing ventilation system inside it.
Right, so this African mound isn't just a static structure. It is actively managing its own internal climate. You can basically think of it as a solar-powered, self-regulating air conditioning system.
And the secret behind it all? It comes down to a super basic principle of physics that you probably remember from school: convection. Simple, right? Hot air rises, cool air sinks. The termites have just figured out how to harness this simple force with, honestly, breathtaking elegance. In fact, researchers have this amazing name for it. They call the mound an external lung for the whole colony. And get this, it doesn't use the colony's own body heat to drive the airflow. No, that'd be inefficient. Instead, it uses the free, abundant energy from the sun. The whole structure literally breathes in and out once every single day.
So how does it work? Okay, picture this. In the morning, the sun rises and starts heating the air in the mound's outer tunnels. That hot air starts to rise. By midday, this creates a really powerful upward draft, almost like a vacuum, pulling all that stale, CO2-heavy air from the nest deep underground, up through a central chimney, and poof, out the top. Then, as the sun sets and everything cools down, the whole process flips. The airflow reverses and cool, fresh air gets drawn down into the nest for the night. It's genius.
And check this out. This is a plaster cast of the inside of a mound, and it shows you the incredible structure that makes all this possible. It's not a solid block of mud at all. It's this porous, almost sponge-like network of tiny tunnels and channels, a massive surface area that's all designed for one single purpose: exchanging gases with the outside world.
Okay, so that explains the air conditioning. Pretty cool, right? But it still doesn't explain the big question. How do millions of blind insects actually coordinate to build this incredibly complex lung? Well, it turns out the answer lies in a totally different environmental factor. You know, for a long time, the classic theory was all about pheromones, chemical signals. But the latest evidence points to something much, much simpler and honestly way more elegant. It's not about what the termites smell, it's about what they feel. Okay, so inside the mound, the air is just incredibly humid. We're talking over 90% relative humidity, and this is absolutely essential for the termites and their fungus farms to survive. But just outside in the dry savanna, the air is, well, it's not. And that massive difference, that's the key.
So it all comes down to this really elegant feedback loop. Here's how it goes. A worker termite brings a little pellet of wet soil up from underground. That wet soil creates a tiny bubble of high humidity right around it. Now, the termites love this humid air, so they move around freely inside this little comfort bubble. But the second their antennae touch the edge and sense that sharp drop-off to the dry outside air, it's like hitting an invisible wall. So what do? They drop their wet soil right there, on the boundary. And that one simple act extends the humid bubble just a tiny bit further, creating a new edge for the next worker to find. And through this incredibly simple, totally decentralized process. The entire mound grows. The termites aren't following some grand blueprint. They're literally just chasing a moving border of humid air. Think about that. They're not just building a structure. They're building a climate. And the physical mound is just the result.
I mean, this is incredible biology, but the story absolutely does not end there. Because if nature has spent millions of years perfecting this kind of climate control, well, maybe we should be taking some notes.
So could we humans actually build like this? That's the huge question behind a whole field of design called biomimicry. Can we solve our own problems by copying nature's time-tested strategies? Basically, instead of trying to reinvent the wheel every time, biomimicry looks to the blueprints that evolution has already spent millions of years perfecting. And when it comes to sustainable architecture, well, the termite mound is a total masterclass.
I mean, think about our modern office buildings, right? They're often these big sealed glass boxes. They are unbelievably expensive to heat in the winter and cool in the summer. They rely on these massive energy-guzzling HVAC systems, and to save a buck, they often just recycle the same stale, polluted indoor air over and over again. Surely there has to be a better way.
And there is. This right here is the Eastgate Center in Harare, Zimbabwe. It was designed by an architect named Mick Pierce. And this building, a whole shopping center and office block, has no conventional air conditioning at all, yet it stays comfortable all year round. And its inspiration? You guessed it, the local termite mounds. The building basically mimics the termite strategy. During the cool nights, low-energy fans pull air into the building's core. The heavy concrete and brick act like a sponge, absorbing all of that nighttime coolth. Then, during the day, as the building and all the people inside generate heat, that stored coolness is slowly released into the offices. And just like the mound, the warm, stale air rises naturally, thanks to good old convection, and gets vented out through chimneys on the roof. The result is staggering. It uses less than 10% of the energy of a similar-sized conventional building.
So the Eastgate Center is way more than just one clever building. It's really a proof of concept. It shows a whole new way of thinking about architecture is possible.
And as one researcher, Dr. Rupert Sower, puts it, we're right on the brink of being able to build more like nature. With new tech like large-scale 3D printing, we can actually start designing structures with the same kind of beautiful complexity we see in a termite mound. Imagine walls with these intricate internal networks that manage air, heat, and moisture, creating what he calls a true living, breathing building. When you think about it, the termite mound is a radical idea hiding in plain sight. It's a powerful reminder that the best solutions aren't always about inventing some brand new piece of tech. Sometimes it's just about paying closer attention to the genius that's already all around us in the natural world. And it really makes you wonder, doesn't it? What other revolutionary blueprints are out there, right outside our doors, just waiting for us to notice?